Okay. Okay. So today we'll discuss about software quality assurance approaches. Okay. So what are the different approaches for software quality assurance? So there are some different approaches are there. That is formal approach. Okay. Formal approaches to software quality assurance. That is a statistical software quality assurance, software reliability, ISO standards. Okay. ISO quality standards and CMM levels and software quality assurance plan. So these are some of the formal approaches to the software quality assurance. Okay. So today we'll discuss about the statistical software quality assurance. Okay. What are the statistical approach? What are the statistical approach? The formal approach of the software quality assurance. Okay. So the statistical means to collect and categorize the information about the software defects that occur. Okay, we need to collect the data. Okay, collect the information and categorize what actually the causes. Okay, where the defects are arising. Okay, collect and categorize the information, that is causes about the software defect that occur. Okay, so that is the this is the process how we can statistically how we can analyze the software quality assurance. So collect and categorize the information, that is causes about the software defects that occur, where the software defects are occurring. Attempts to trace each defects. Okay, attempt to trace or find out the defects to its underlying causes. Example means because of the non-conformation to the specification, or because of the design error, or because of the violation of the standards. Okay, or because of the poor communication with the customer. So there are so many reasons are there. Okay, because of these reasons, okay, there are defects are arising in the software. So attempt to trace each defect, attempt to find out where the defect is occurring. Okay, and the defects that occur, the error defects that occur in a software, it is due to various reasons, because of the non-conformation of the specification, or because of the design error in the software, or violation of the standards. Okay, or any poor communication with the customer. There are so many reasons are there. Okay, so attempt to trace a defect using the Pareto principle. So this Pareto principle, it is also called as the 80-20 principle. Okay, 80-20 principle. So what actually this 80-20 principle means? Okay, we will discuss that 80-20 principle, that is called as the Pareto principle. So here the statistical testing that make uses of the statistical methods to determine the reliability of the program. We are using the one of the standard formal approach, one of the standard formal approach of statistical method to determine the reliability of the program. So the statistical testing mainly focus on how the faulty programs can defect its operating condition. So how we can perform this statistical testing method in software testing is software is tested with the test data that statistically models the working environment. The failures are collated and analyzed. The defects from the computed data and estimate the program's failure rate is calculated. Okay, with the computed data we can estimate the failure rate. The statistical method for testing the possible paths is computed by building the algebraic function. Statistical testing is a bootless activity as the intent is not to find defects. So this 80-20 rule, this 80-20 rule, it defines a Pareto principle in which asserts that 80% of the outcome or the output, okay, 80% of the outcome or the output result from the 20% of all the causes or the inputs for a given event. Okay, 80-20 principle means 80% of the outcome, 80% of the output, okay, the defects, okay, 80% of the defects, okay, the 80% of the outcome that results, okay, the 80% of the outcome that results from the 20 percentage, 20 percentage of the all the problems or the inputs for a given input. Okay, means for example you can say like the business organization, any business organization, okay, there is 80% profit to the organization because of the 20 customer, 20% of the customer. Okay, 80-20% 20 rule means in software testing, okay, the 80% of the outcome or output, 80% of the result from the 20% of the all causes or the inputs for any given event. Okay, so that is 80-20 rule. That is also called as a Pareto principle. It is also called as Pareto principle. 80% of the outcome or output, it results from the 20% of the all causes or the input for a given event. In business, a goal of 80-20 rule is to identify the inputs that are potentially the most productive and make them priority. Okay, so in the business, okay, so this 80-20% means, for example, is as I told, like for any business, if there is 80% profit is getting from only 20% of the customer, okay, from 20% of the customer they are getting the 80% of profits, means we can use this statistical data for the analysis. Okay, so the 80 percentage of the defects or the outcome means 80% of the outcome or output result from the 20% of all the causes or inputs for a given event. So this particular 80% 80-20 rule or Pareto principle, it is mainly here 80% of the defects that can be traced to 20% of all the causes, means using the Pareto principle, finding the 80 percentage of defects, 80% of defect can be find out from the 20 percentage of all the causes or the inputs. Okay, 80 percentage of the finding the defects or tracing the 80 means we are covering maximum defects, that indicates we are covering the maximum coverage of defect in a particular module or any system. Okay, means you are finding the 80 percentage of defects that can be traced, or you can find out to 20% of all the causes, or the 20% of a given input. So this particular a sample of all the possible causes for the defect, means this defects, how the defects occurs. The defects occur because of the many reason, like incomplete the customer specification, or any error in the customer specification. Okay, so there is a incomplete or error in the specification, misinterpretation of customer communication. Okay, the understanding the requirements. Okay, so the developer, the misinterpretation of the customer requirements, an intentional deviation from the specification. Okay, means the customer requirements are different, and the whatever they are developing, the developer, they are considering the requirements are different. Intentional deviation from the specification of a software, violation of programming standards. Okay, not following the programming standards for implementation, errors in data representation, inconsistent component interface, the module interface. So because of all this, error in the design logic, incomplete or erroneous testing, incomplete testing process, inaccurate or incomplete documentation, errors in the programming language, translation of design, means while translation from design to coding. Okay, while converting your design of the software to the implementation, so error and ambiguous or inconsistent human computer interface. So because of all these reasons, okay, the defects are arise. Okay, so this is one of the approach, the Pareto principle, where the 80% of the defects that can be traced to 20% of all the causes. Okay, means finding out the 80% of the defects from a 20 percentage of the given input. Means here we are covering the maximum the coverage, we are covering the defects. Okay, so that is a one approach, Pareto principle, in the statistical approach of software testing. And then the Six Sigma is the one more method. So this Six Sigma term, that refers to the set of quality control tools. Six Sigma. Okay, Six Sigma is that refers to the quality control tools that helps the business to eliminate the defect and improve the process to help the boost their profits. Okay, to maximize the profit in the organization. So that is a Six Sigma technique. So this Six Sigma uh, statistical this Six Sigma testing, this method also we use in the to improve the quality of the software. So actually this Six Sigma, it was developed by a scientist in the 1980 while he was working at the Motorola. So what is this Six Sigma? Is a process of producing the high and improved quality output. Okay, so the main is the approach. What is the main the goal of this Six Sigma is to produce the high and improved quality output. This can be done in two phases. One is identification and elimination. Six Sigma process means you need to identify the defects and elimination. So the cause of defects is identified and appropriate elimination is done, which reduces the variation in whole process. Okay, so identification and elimination. Identification of defects and elimination, that is the main steps involved in the Six Sigma, which reduces the variation. Okay, which reduces the variation in whole process. A Six Sigma method is the one in which 99.99% of all the products to be produced have the same features and are free from the defects. Free from the defects. So, as this is a Six Sigma curve, Six Sigma statistical benchmark that shows how a business process works. Okay, an error happens when the event occurs with 6 standard deviation. Okay, with 6 standard deviation from the mean with no more than 3.4 occurrence. No more than 3.4 occurrence per million events. 3.4 defects per 3.4 defects per million. This means that the process is considered to be efficient if it produces less than 3.4 defects. If it produces the less than 3.4 defects per million, 1 million chance. 3.4 defects per 1 million chances. A defect is anything that is produced outside of the consumer satisfaction. Okay, 3.4 defects per million means the Six Sigma statistical approach, where it is considered efficient as it produces less than 3.4 less than 3.4 defects per 1 million chance. Okay, less than 3.4 defects per million chance. 3.4 defects per million chance. So that is a Six Sigma curve. This is bell shaped, defect free. By using this Six Sigma approach, the quality of the software is that we can say it's a 99.99% defect free. These are some formal approaches to improve the quality of the software. So this particular Six Sigma approach, it is popularized by the Motorola in 1980s, and it is most widely used strategy for statistical quality assurance. Okay, this is widely used technique for the statistical quality assurance and uses for the data and statistical analysis to measure and improve the company's operational performance. It identifies and eliminates the defects. Identify and eliminate the defects in manufacturing and service related process. Actually, it is this particular Six Sigma. This techniques used in uh, manufacturing and service related process. But it is one of the techniques that improve the quality, software quality. Six Sigma refers to the six standard deviation. Six standard deviation, that is 3.4 defects per a million occurrence, means less than 3.4 defects per million. Okay, the Six Sigma deviation is there, no? This refers to the 3.4 defects per million occurrence. 3.4 defects per million occurrences. There are 5 steps mainly involved in the Six Sigma, this statistical quality assurance process, that we call it as D, M, A, DMAIC. Okay, so the Six Sigma that contain these 5 steps: define, measure, analyze, improve, and control. Okay, define, measure, analyze, improve, and control. Define the customer requirements, deliverables, and project goals through a well-defined methods of customer communication. Okay, the Six Sigma that contains these 5 steps: define the customer requirements. Deliverables means the output what we are delivering to the customer. Project goals that are well defined methods of customer communication. Measure the existing process and its output to determine the current quality performance. Analyze the defect metrics and determine a vital few causes. Okay, measure, analyze, and improve the process by eliminating the root causes of the defects. Improve the process by eliminating the main root causes of the defects, and control the process to ensure that the future work does not reintroduce the causes of the defect. Controlling the defects. So this applicable in all the process, in manufacturing process, in software development. Okay, define, measure, analyze, improve, and control. The Six Sigma approach: define customer requirement, measure process its outcome, analyze, improve the process by eliminating the root causes of the defects, and control the process. Control so that in the future it should not reintroduce the causes of the defects. Okay, it does not reintroduce the causes of the defects.